G'day and welcome to the first video on integration, chapter 7 in your textbook. Now this integration is sort of the reverse of differentiation. Sometimes we call it anti-differentiation as well. And I guess if you've got a good understanding of differentiation, then you probably, if you can kind of just see it in reverse, it should be okay for you. So on the left hand side here I've got y equals f of x, just some function. If I get the derivative, I'm going to get f dash of x. Now when that's what we've done in differentiation. In integration, if I integrate f dash of x, and this is the little integration signs here, which I think you've seen before, this little sort of big long elongated s and dx, if you integrate it, it actually becomes f of x back to the original function again. Okay, so there are a couple of rules, a couple of things you need to know, and again I'm going to use, I guess, differentiation to kind of use that as I guess our platform. So when we do the derivative of something, or when we do differentiation, imagine if I've got this here, f of x equals ax to the n plus 1 over n plus 1. When I do the derivative, I multiply by the power, and I've got it written down on the left hand side here what I do. I multiply by the power, I minus 1 from the power, and then I multiply by the diff of the inside. Now in this case, I don't think there is a diff of the inside because there's no brackets or anything, but that's just something that people forget a little bit. So I multiply by n plus 1, I minus 1 from the power, and then I've got my answer. So that n plus 1 will cancel out with this n plus 1. 1 minus 1 will end up being ax to the power of n. Now if I integrate this, I'm virtually going to do the reverse of what I've done over here. So I'm actually going to add 1 to the power, I'm going to divide by the new power, and then I'm going to divide by the diff of the inside, virtually the reverse, as you can see over here. So I add 1 to the power, make it n plus 1, I divide by the new power, which is n plus 1, and then I divide by the diff of the inside. In this case there is no diff of the inside. Now I should get back to what I had originally, and that's exactly right. Now you will notice that I've got this plus c over here. This plus c is a constant, because what could happen is that I could have over here, I could have plus 6, for instance. Now when I differentiate that plus 6 will reduce down to 0 because there's no x attached to it. But what all this here is saying, plus c, is that there could be some constant that we haven't taken into account of. And I'm going to say that every time in year 12 you must have a plus c at the end of it. There are 1 or 2 exceptions, as there always is. But my encouragement is that you should always put in plus c, because it recognises that it could be a plus 6 or a plus anything. But c could end up being 0, which in case that that would be this plus 6 would disappear. But it's good to recognise that it would be there anyway. Okay, let me go through a couple of rules that you can apply with anti-differentiation or integrating. The first rule is if you've got two things added together, two functions added together, and it simply could just be x plus x squared. Those are just two functions added together, x and x squared. You can actually separate them and do the integration separately. The tricky thing here is, and this is where people will lose a lot of marks, you have to have a dx. Don't drop the dx after each integration sign. Okay, often they look for that in exams, and if you don't have it, then you can lose a mark potentially. Another one here, if k is just some random constant, okay, it could just be 3 or 7 or a, it doesn't really matter. It's just a constant. If it is a constant, you can actually drag it out the front of the integration sign because it won't make any difference to the integration. So for example, I could have 3x dx. That would be the same as 3 times x dx. Okay, that's kind of what I mean for that one there. Just rub these things out. The next rule I will show you is if you've got x to the power of anything except -1, and I'll go through that a little bit later, x to the power of anything, when you integrate that, you'll add 1 to the power and then you'll divide by the new power plus c. Okay, so even if n is a half, even if n is a fraction, a decimal, a negative number, a positive number, the only exception is when n equals -1, and I'll go through that a little bit later. Okay, in fact I'll go through that now. If x is equal to -1, then that turns out to be the integration of 1 on x, that's the same thing. X is -1 and 1 on x, the same thing. That ends up actually being natural log of absolute value of x plus c. Now I might go through that a little bit later, but I just wanted to show you what happens with that now. Okay, because there's particular reasons why that happens. The other thing I'll say to this is that there is no product rule or quotient rule for integration. So, for example, if you get something like this, x sine x, okay, two things multiplied together, you can't actually do the integration of this using a product rule or a quotient rule or anything like that. For differentiation, we would use the product rule for this, and get the first times the diff of the second plus the second times the diff of the first. But for integration, there is no such rule that can be applied. We can actually find the answer to this, but it's a little bit more tricky. We need to use some manipulation in order to get that. Okay, so that's the basics of integration. I'll just go back up to the start and show you that integration is adding one. Where are we? Stop now. Stop. Oh, mind of its own. So when we integrate, we add 1 to the power, we divide by the new power, and we divide by the diff of the inside. Okay. In the next video, I'll have a couple of examples to go through. So yeah, thanks for watching, and I'll see you in the next one.